Okay, so we're going to do a couple of questions or four different questions on finding the rule. So this is something that we've needed to do is to have a look at some values of x and some values of y and find the equation that describes the relationship between these numbers. And what this means, find the rule and express as an equation in the form of y equals mx plus b. Now, we haven't seen this y equals mx plus b before, but all this is showing is the kind of equation that will be the rule. Okay, so we'll have y will be equal to something times x plus something. Now, we need to remember this m, whatever this m is, the thing we need to try and find out, can be positive or negative, and so can our b be positive or negative. So our equations will be y equals something times x plus or minus something. Okay, let's have a look at our first one over here. So we're told that if when x is 1, y is 4, when x is 2, y is 6, when x is 3, y is 8, when x is 5, y is 12. So all of these values, they follow the same rule. Okay, so let's look at our first term, our x equals 1, and we'll see what relationship it has between the x value and the y value. Well, x is 1 and y is 4. So, okay, well, what if it was y equals 4 times x? Okay, and, b was 0, so 4 times x plus 0, so we don't even have to worry about our plus 0 in this case. Well, that holds for this one. 4 times x is 4, but doesn't work for this one. 2 times 4 is not 6, so that can't be correct. Well, what about if it was 3 lots of x plus 1? Well, 3 lots of 1 plus 1 would equal 4, so y equals 3 lots of x plus 1. That works for that one. Does it work for this one? 3 lots of x would be 6 plus 1 would be 7, so it doesn't work for this one as well. So again, our rule doesn't work. Okay, let's have a look at some of our other values here. Well, 6 is 3 times x, so 6 is 3 times 2, but that's not 3 times 1, so it can't be just 3x. What about 3 and 8? Well, 3 times 3 is 9. What if it's 3 times x minus 1? Y equals 3 times x minus 1. Does that fit for the rest of them? Well, 3 times 5 minus 1 is not 12, so that can't be correct either. So you see there's a lot of guessing and checking involved here. Now, this one I think is going to help us the most. 5 times 2 plus 2 is equal to 12. 5 times 2 plus 2. Let's see if this one works out. So, our 2 times our x, 5, plus 2. Well, in this case, 2 times 3 plus 2 would equal 8, because 2 times 3 is 6, plus 2 is 8. So that's correct for that one. It works for this one already. 2 times 2 plus 2 is 4 plus 2, which is equal to 6. And 2 times 1 plus 2 is also equal to 4. So 2 times x plus 2 is our correct rule for that. You see, there's a lot of guessing and checking, but it's all educated guesses based on these numbers. It's a bit of a detective game. Let's have a look at our next one. So, well, look at this one. If we double this one, we get here, but so we could just say y equals 2x, but y equals 2x doesn't fit for the rest of these. 5 is not double 2, 8 is not double 3, 14 is not double 5, so it can't be that one. What else? What about if we simply add 1 plus 1, so x plus 1? Well, that's not going to work for these either. Okay, let's think about possibilities where we have a negative value. Now, it's not going to be a negative m because we don't have negative terms down here, but what if b was negative? What if it was something times x minus something instead? Well, what if it was just 3 times 1? Okay, 3 times 1 would be 3, and what do we need to minus to get to 2? Well, it'll just have to be 1. So let's try this one out. 3 times x minus 1. Does that fit for these? 3 times 2 is 6, minus 1 is 5, so that one works. 3 times 3 minus 1 equals 9. So that one works as well. And 3 times 5 is 15 minus 1 equals 14. So this rule works for these ones right here. So this is our rule. This next one. Now, notice the patterns that we have each time. We go up by 1 for these ones here. 6, 7, 8, 6, 7, 8, 6, 7, 8. And if we had our fourth term in there, it would be 9, and a fifth term would be 10, of course. So this one is likely going to be just adding a number each time. Okay, just adding a number each time because we don't have something being multiplied. So how do we get from 1 to 6? Well, we have to add 5. Excuse the very long bell. We have to add 5 to get from 1 to 6. So let's try x plus 5. Does that fit for here? 2 plus 5 is 7. 3 plus 5 is 8. 5 plus 5 is 10. Yep, that works. So not only looking at the individual pairs, but also the relationship between these bottom numbers can also give us clues as to what the rule is. Let's try that for the next one. 4, 8, 12, 20. Okay, well, let's just go these 3 terms here, simply because they're in order, 1, 2, 3. 4, 8, 12. Well, 4, 8, 12 is adding 4 each time, isn't it? Adding 4 each time. So this one here is actually 1 times 4. This one here is 2 times 4, and this one here is 3 times 4. So our rule right here can be y equals 4x. 4 lots of 1 is 4. 4 lots of 2 is 8. 4 lots of 3 is 12. And 4 lots of 5 is 20. And so our rule checks out. Now, you might be thinking, I'm not going to get any of these ones. I'm going to, it takes so much guessing, it takes so much working out. But I'm telling you, the way we get to it is detective work. We look at the relationship between these numbers, and we look at the relationship between each of the pairs. So what do 5 and 10 have in common? Or how do we get from 5 to 10? How do we get from 3 to 8? And think about possible ways that you could do that. And they must all be the same. So if it works for this pair and doesn't work for this one, it can't be our rule. It must work for all 4 pairs or for all pairs that are there.